Hey everyone, welcome back to the Edexcel IAL Maths paper series. So today we're going to talk about the October 2023 P4 paper. So in the previous video we talked about P3, now we're going to talk about the P4 paper. All right, so let's see question number 1. Find the first four terms in the ascending powers of x of the binomial expansion of this. So first off, we need to deal with this. We need it in 1 plus or minus ax raised to power n form. So we have this 2 minus 5x whole squared. Let's just start from this. When we factorize out to 2, we get 1 minus 5 over 2x, which means that if you have a square over here, you will have a square over here. And if you have a minus 2 over here, you will have a minus 2 over here also, which would mean 2 raised to power minus 2 is 1 over 4, and this would be 1 minus 5 over 2x raised to power minus 2. 8, when you multiply this by 8, so 8 times by 2 minus 5x raised to power minus 2, this will become 8 divided by 4, 2. 1 minus 5 over 2x raised to power minus 2. So first we need to expand this and then we will multiply the 2 back in. So 1 minus 5 over 2x raised to power minus 2. We know the formula. If you're not familiar with the formula, I'll write it over here. So if you have 1 plus ax raised to power n, this can be estimated or expanded by 1 plus n times by ax plus n times by n minus 1, 2 factorial ax whole squared, and n minus 1, n minus 2, 2 factorial ax whole cubed, and so on. So these are the first four terms in the ascending powers of x. So that's what we're going to do. So 1 plus minus 2 minus 5 over 2x plus minus 2 minus 3 divided by 2 factorial minus 5 over 2x whole squared plus minus 2 minus 3 minus 4 3 factorial minus 5 over 2x cubed. So let's expand. So 1, 2 and 2 and minus minus get cancelled. We are left with 5x plus 2 times by 3 divided by 2 times by 25 divided by 4. So we get this value, which is 75 over 4. X squared plus, so minus 2 times by minus 3 times by minus 4 divided by 3 factorial times by 5 cubed, that is minus 125 divided by 8. So we get 125 over 2x cubed. Now, what was left over here, we had a 2 over here. So 2 times by 1 minus 5 over 2x raised to power minus 2. We'll see 2 multiplied with all of these terms. So 1 times by 2, 2 times by 5x, 10x. 2 times by 75 over 4, that becomes 75 over 2x squared. And 2 times by 125 over 2 is just 125x cubed. And that's our expansion up to x cubed. Oh, sorry, first 4 bytes. Find the range of values of x for which this expansion is valid. So basically, this thing is less than 1. So for the b part, mod 5 over 2x less than 1. So 5 over 2 is a constant. So it can be taken on the outside and on the other side. So this would be 2 over 5. That's it. All right, moving on to the next question. Figure 1 shows a cube which is increasing in size. At time t seconds, the length of each cube is x centimeter, surface area is s, volume is v. Given that the surface area of the cube is increasing at a constant rate of 4 centimeters squared. So that means ds over dt, it's increasing, so plus 4 centimeters squared per second, all right? Show that dx over dt is this. Okay, so first off, we need to know what the surface area is. Since this is a cube, so this is 6 times by x squared. So that means that ds over dx is 12x. So we need dx over dt. So for dx over dt, we need to employ a chain rule. Dx over ds times by ds over dt. So dx over ds is reciprocal of this, 1 over 12x, times by ds over dt, which is 4. So this becomes 1 over 3x. Similarly, show that dv over dt is v raised to power p. Okay. So volume is simply x cubed. So that means dv over dx is 3x squared. So this must mean that if we want dv over dt, we have to employ a similar chain rule that we worked in the a part. dv over dx times by dx over dt. So dv over dx is 3x squared, and dx over dt is 1 over 3x. So we are left with just x, right? So what do we have over here? Right, okay. So x itself, since we know that the cube of x is v, this is equal to the cube root of the volume. And that was a very small question. All right, question number 3. Use integration by parts to find the exact value of this, giving your answer in the simplest form. So I will show you 2 ways to do this, both the table method also, and the DI method also, and the way that we have been doing in the classes. So integration by parts, when you have u, v, dx, we have u integral v dx minus whole integral u prime integral v dx whole dx. Either way, like whichever way your teachers or you've seen that on YouTube, it would more or less be the same thing. So how do we choose u with this rule or this rule? The purpose is to simplify the u first, or we have to choose u in such a way that it can be further simplified. So u obviously is x squared. This means that u prime is 2x. V is e raised to power 2x, so that means integral v dx is e2x over 2. So when we use x squared cos 2x, no, oh my bad, e raised to power 2x dx, yeah, all right. We get u times by this, so half x squared e raised to power 2x minus integral u prime times by this, x 2 and 2 cancel, so x e raised to power 2x dx. Now, this will require another step. We will do the same thing. So u is equal to x, u prime is equal to 1. v is equal to e raised to power 2x. So integral v dx would be e raised to power 2x over 2. So same thing. So half x squared e raised to power 2x minus 1 over 2x e raised to power 2x minus integral of e raised to power 2x times by over 2 times by 1 and dx. So this becomes 1 over 2 x squared 2x minus 1 over 2x raised to power 2x plus this becomes 1 over 4 e raised to power 2x plus c. Now, let's see the same thing with the table method or the DI method, whichever one you want to call it. So in first column, we select the U, and in the second column, we choose the V. That means in the first column, we start with the U, which is, let's say, our x squared, and we differentiate it until we get a 0. In the integral part, we choose the V, that was e raised to power 2x. The integral, that would be e 2x over 2, e raised to power 2x over 4, and e raised to power 2x over 8. Now, how do we get the terms? The first term will have the plus sign, the second negative, and plus alternate. So when we combine the terms, this will turn out to be x squared e raised to power 2x dx, x squared e raised to power 2x over 2 minus 2 times by 1 over 4 is 1 over 2 also. So 1 over 2 x e raised to power 2x plus 2 times by 1 over 8, that is 1 over 4 e raised to power 2x plus c. Just to compare, that's exactly what we had over here. So this method, it needs to be correct to get the correct answer mark. All right, so use integration by substitution to show that 4x over 2x minus 1 whole squared can be written as this. Okay, so we need to use substitution over here. So let's see how much space. Okay, we have a lot of space. So 4x over 2x minus 1 whole squared from 3 to 21 over 2. Okay, so what we can do over here, we can choose this to be u. Have they given us any substitution? Oh, no, they haven't. All right, we can choose it, anything. So u can be our 2x minus 1, which means that 2x minus 1 whole squared is our u squared. Similarly, du over dx would just be 2. And the 4x we see over here, we need to see what that is. So if 2x is u plus 1, that means 4x is going to be 2u plus 2. So this is what we are going to work with. Alternative method could be that if you could use the square as u also, but I don't think that would be very easy because then you would find it very difficult to substitute 4x. So, all right, so once we do that, 4x is 2 times by u plus 1 divided by, this is u squared. And we have to choose the limits also. So when x is equal to 3, u is equal to 2 times by 3 minus 1, so 5. And when x is equal to 21 over 2, u is equal to 2 times by 21 over 2 minus 1, so just 20. So from 5 to 20, and du or basically, sorry, the dx over here is du over 2. So 1 over 2 du. So 2 and 2 are getting canceled over here. However, how do we simplify this further? So we can do this as u over u squared plus 1 over u squared du 5, 20. So basically this is just 1 over u. And the integration is now easy because this is just ln u, and this is going to be u raised to power minus 1 over minus 1. So u raised to power minus 1 over minus 1 from 5 to 20. Right, now let's simplify. So ln 20 minus 1 over 20 minus ln 5 minus 1 over 5. So this would become ln 20 minus ln 5 and minus 1 over 20 plus 1 over 5. So these two can become ln 20 divided by 5. That is just going to be 4. And so 1 divided by 5 minus 1 divided by 20, that is 3 over 20. That's it. That's your final answer. All right, moving, wait, sorry. All right, that's the second part. All right, moving on. Prove by contradiction that for all positive numbers k plus 9 over k is greater than or equal to 6. So prove by contradiction. So we need to write a contradictory statement first. So the assumption is that for all positive numbers, it is assumed that for all positive numbers k plus 9 over k is less than 6. See, the mutually exclusive case for greater than or equal to 6 is less than 6. So if this is the case, we have k plus 9 over k less than 6. We multiply k on both sides. We get k squared. 6k comes on this side. And plus 9 less than 0. This obviously is a perfect square of k minus 3 whole squared less than 0. We know that perfect squares touch 0 and are greater than or equal to 0. So this is why no value for k would satisfy this inequality. So square numbers are always greater than or equal to 0. Hence, the assumption is false. Therefore, for all positive numbers k plus 9 over k is greater than or equal to 6. Right? Okay. Oh, sorry. No. Show that the result in part A is not true for all real numbers. So in the A part, we said k was positive numbers. So k was a positive number. Not all real numbers means why is it not suitable for negative numbers. So if k is less than 0, 1 over k would still be less than 0. However, like it would be larger in magnitude, but it would be a larger number. Magnitude-wise, it would be larger. So this must mean that 9 over k also is less than 0. So k plus 9 over k is less than 0 and cannot be greater than 0.6 at the same time. Oh no, sorry, no. Cannot be greater than 6. That's it. Therefore, the rule does not hold this relationship. Therefore, the result does not hold for all real numbers. Okay, moving on. Question number 5. Figure 2 shows a sketch of the curve C with equation this, where k is a positive constant greater than 1. Find dy by dx in terms of x and y. Okay, so this is implicit differentiation. So d by dx of y cubed minus x squared plus 4x squared y equals to k. So this y cubed becomes 3y squared dy by dx. Wherever there's a y term, it will be having dy by dx minus 2x plus this thing now will be dealt with the product rule. So 4x squared dy by dx plus y times y 8x equal to 0 because k is a constant. Now we simplify and make dy by dx the subject. So dy by dx 3y squared plus 4x squared equals to 2x minus 8xy. So that means dy by dx is equal to 2x minus 8xy divided by 3y squared plus 4x squared. Right. The point P lies on C. Okay. Given that the normal to C at P has equation y is equal to x, find the value of k. So y is equal to x is the normal. That means the tangent or the gradient at this point is minus 1. So gradient or dy by dx at P is minus 1. So we need to figure out where it is minus 1. dy by dx is minus 1. So first we will find out the coordinate. So therefore, we have 2x minus 8xy equals to minus 3y squared minus 4x squared. We also know that y is equal to x on this line. So this is what we're looking for. So we can substitute this over here. So 2x minus 8x squared because y is equal to x. And this can become 3x squared. And this can remain 4x squared. So when we take everything on one side, 4 plus 3 minus 8, that is going to be 2x minus x squared equal to 0. So x 2 minus x equal to 0. So either x is equal to 0 or x is equal to 2. So that means the x coordinate of P is 2. So that means, and y is equal to x also, so y is also 2. So that means y is equal to 2 also. So coordinates of P. So y cubed plus, sorry, minus x squared plus 4x squared y equals to k. So plugging in 2 comma 2, you get 2 cubed minus 2 squared plus 4 2 cubed equals to k. So 8 minus 4 plus 4 times by 8, 32. So 32 plus 8 minus 4, that is 36. That is your k. So therefore, k is 36. Simple, straightforward. All right, moving on to question number 6. The line L1 has equation r is equal to 2, 3 minus 7 plus lambda 1, 2, 2, where lambda is a scalar parameter. Line L2 has equation r is equal to 2, 3 minus 7 plus mu 4 minus 1, 8. Given that L1 and L2 meet at point P, find the coordinates of P. So this doesn't require any calculation because this is staring us at right on our faces. So we just needed to state it, not find or calculate. So point of intersection is 2, 3, 7. Which one was negative? Minus 7. Right. Okay. Oh, the coordinates. Coordinates. Sorry, not position vector, coordinates. So 2, 3, minus 7. Okay. Given that the angle between the lines L1 and L2 is theta, find the value of cosine theta giving the answer as a fully simplified fraction. So whenever we want to find out the angle between two lines, we just need their direction vectors. So we need the dot product between their direction vectors. So 1, 1, 8. Sorry, no, sorry. 1, 2, 2, and 4 minus 1, 8. Just to make sure that we have the right thing. Yes, okay, all right. And this is equal to 1 squared plus 2 squared plus 2 squared whole under root times by 4 squared plus 1 squared plus 8 squared times by cosine theta. So the left-hand side, the dot product itself, 1 times by 4 minus 2 plus 16 equals to 4 plus 4, 8. 8 plus 1, 9. 9 square root is 3 times by 16 plus 1 plus 64. That is also 9 times by cosine theta. So 2 plus 16 is 18 divided by 27 equals to cos theta. So therefore, cos theta is equal to 18 divided by 27. That is 2 by 3. So the theta would be the cos inverse of 2 over 3. So cos inverse of 2 divided by 3, that is in degrees, 48.2 degrees. Oh, my bad. Sorry. The question was just cosine theta. So this is the answer. We don't need to find the theta. Sorry. Okay. The point Q lies on L1 where lambda is equal to 6. Given that the point R lies on L2 such that the triangle QPR is an isosceles triangle with PQ is equal to PR. Find the exact area of triangle QPR. Okay, so first off, these are two lines, L1, L2. This is the point of intersection. This is P, and that's 2, 3, minus 7. Angle between them is 48.2. So, and all right, so there's a point on Q, there's a point on R, which makes PQR with PQ equals to PR isosceles triangle. Find the exact area of the triangle QPR. So this is straightforward. All we need to do is we need to find out the half AB sine theta. So we need to find out PQ and PR. So that's what we're going to figure out. Where lambda is equal to 6, so we need to find out PQ. So PQ, see, we already know we're starting from P and plus some lambda vector that will get us to Q. So OP plus this, that will get us to OQ. No, yes, Q. So they have given us the lambda 6. So if we just simplify that out, we will get OQ minus OP, which is equal to PQ. So we just need the vector. So PQ is equal to 6 times by 1, 2, 2. So this is 6, 12, 12. So that means the length PQ is 6 squared plus 12 squared plus 12 squared. So square root 36 plus 144 times by 2, we get square root 18. So area of triangle, this is the B part, PQR, half AB sine of theta. We need to figure out the sine theta from over here. So we have multiple ways of doing this. So let's write over here. We can use a triangle method. So if this is theta, cosine is 2 and 3. So you could do, for this side, you could do 3 squared minus 2 squared. 9 minus 4, 5 squared. 9 minus 4, 5. And this would be square root 5. Another method is to know that sine squared theta is 1 minus cos squared theta. So that would be 1 minus 4 over 9, which is 5 over 9. So sine theta would be square root 5 over 3 plus minus, but since we're talking about an acute angle, because cosine, we got a positive cosine value, so it's either in the first quadrant or in the fourth quadrant. So obviously acute angle. So we need a positive 5 over 3. So positive root 5 over 3. So instead of sine theta, we can write sine theta over here somewhere. So sine theta is equal to square root 5 over 3. And you will actually have to write the entire method, at least like some snippet over here to justify. So square root 5 over 3. So 0.5 times by 18 times by 18 times by square root 5 divided by 3. We get this 54 square root 5. They did not ask us about the, okay, so they needed the exact area. So that's the exact area. Find the coordinates of the possible positions of point R. So we know the distance, 18 units. So we just have to start from P along this line. So PQ is equal to PR. So PQ length is equal to PR. So that is equal to 18. So PR is going to be mu times by 4 minus 1, 8. Sorry, 4 minus 1, 8. So we need length of this PR in such a way. Oh, sorry, this would become 4 mu, this would become minus mu, this is going to be 8 mu, PR. So PR would become, or PR squared would become 4 mu whole squared plus mu squared plus 8 mu whole squared, and that is equal to 18 squared. Yes, 18 squared. So 18 squared is equal to 16 mu squared plus, sorry, this is just mu whole squared. So mu squared plus 64 mu squared. So 17 plus 64, 81 mu squared, and 18 times by 18 is 324. So mu is going to be 324 over 81. We get 4 squared, 4. So therefore mu is equal to plus minus 2. So find the possible positions of point R. So that means we can start on the line 2. So possible point R starts from either, wait, sorry, what was the starting point? 2, 3, minus 7. Plus, this is 4 mu. So we can start out with 2. So 4 minus 1, 8. And 2, 3, minus 7. Minus 2, 4 minus 1, and 8. So we get 2 plus 8, 10. 3 minus 2, 1. Minus 7 plus 16. Minus 7, 9. And 2 minus 8, minus 6. 3 plus 2, 5. And minus 7. Oh, wait, sorry. Minus 7. Oh, sorry. Minus 7, minus 16. So we get minus 23. So possible points are 10, 1, 9. And this will give us minus 6, 5, and minus 23 possible points. So therefore, possible points for R 10, 1, 9, and minus 6, minus 5, oh sorry, plus 5, and minus 23. That's it. Right, okay, moving on to question number 7. The number of goats on an island is being monitored. When monitoring began, there were 3,000 goats on the island. In a simple model, number of goats x in thousands is modeled by the equation, where k is a constant, T is the number of years after monitoring began. Show that K is equal to 1.8. Okay, so we know that at T is equal to 0, X would be 3 because this is in thousands. So don't write X is equal to 3,000. So at T is equal to 0, X was 3. So therefore you have 3 equals to K 9 times by 0 plus 5, and the other 0 plus 3. So that means 5K is equal to 9. Therefore, K is equal to 9 over 5. And 9 divided by 5 is 1.8. That's it. Hence, calculate the long-term population of goats predicted by this model. So long-term. So for this part, we can do two things over here. Either, since we know that this can be further divided, so we can do the long division where we have some quotient plus remainder over divisor. So if we have a maximum number, so it will come in this form. This would be the this whatever quotient that comes out, that would be our maximum number. To get through that, we can also do another thing. We can divide t from both the numerator and denominator. So we have over here x is equal to 1.89t plus 5 divided by 4t plus 3. So when we divide by 3 on every term, oh, sorry, no, t, sorry, not 3, t. We don't need to do that for 1.8 because this is just multiplied. So we get 1.8, 9 plus 5 over t divided by 4 plus 3 by t. Now, when t approaches 0, 1 over t, sorry, when t approaches infinity, 1 over t approaches 0. So therefore, x would approach, see, this term will go to 0, this term will go to 0. 1.8.9 divided by 4. So 1.8 times 1.9 divided by 4, that is 4.05. So this is x. We need the long-term population, so in thousands. So that would be 4050 population. Long-term. Okay. In a second model, the number of goats x in thousands is modeled by this differential equation. Write 3 over x 9 minus 2x in partial fraction form. So 3 over x 9 minus x or 2x? 2x, sorry. So both are linear factors, so we will have either a over x and b over 9 minus 2x. So this means that 3 will be identical to a times by 9 minus 2x plus bx. So one choice of x is 0. So you will get 3a times by 9. So a would be 1/3. Now we can choose any other value of x. We could choose x is equal to 1. So 3a 9 minus 2 plus b. A we already know to be 1 over 3. So 9 minus 2 is 7, 7 over 3. So b is equal to 3 minus 7 over 3. 3 minus 7 divided by 3, that is 2 over 3. So therefore, 3 over x times by 9 minus 2x can be written as 1 over 3x plus 2 over 3, 9 minus 2x. All right, so this is let's solve the differential equation with initial condition to show that x is equal to this. Right, okay, so we have, now when we separate the variables, so x terms come on one side, so you will have 3 over x, 9 minus 2x dx equals to dt. So that's what we have over here. So 3 over x, 9 minus 2x dx equals to dt. So this is what we are integrating. So we know that we just did the partial fractions of this thing. So this would be integrating 1 over 3x plus 2 thirds 9 minus 2x dx equals to dt. So the first one, this is just simply 1/3 of ln of x plus, now the derivative of 9 minus 2x is minus 2, not plus 2. So if you multiply minus over here and multiply a minus outside, so you have a plus over here, minus 1 multiplied over here, and make 2 as minus 1. So that would keep the sign also. So this would become 1/3 of, or minus 1/3 of, because you're multiplying by minus, ln 9 minus 2x. Okay, because this goes away. You're just left with minus 1 over 3. Equals to t plus c. We know that at t is equal to 0, x was, we calculated it to be 3. So we need to find out the c over here. So 1/3 of ln x over 9 minus 2x equals to t plus c. So sorry, 1/3 of ln 3 over 9 minus 6, 3. 2 times by 3, 6, equals to t plus c. So ln 3 over 3, it just becomes ln 1, so it cancels out. So that means, oh sorry, t is also equal to 0. So this would mean that c is equal to 0 also. So which further means that we are left with, therefore, t is equal to 1/3 of ln x over 9 minus 2x. So this would mean that we need to get it in terms of t or x. Okay, all right, we need to get it in x, all right. So this would turn into e raised to power t, or 3t, sorry. So 3t equals to x over 9 minus 2x. So we simplify and make x the subject. We get 9 e raised to power 3t minus 2x e raised to power 3t equals to x. 9 e raised to power 3t is equal to x plus 2x e raised to power 3t, which means that x can be taken out. So 1 plus 2 e raised to power 3 et. So therefore, x is equal to 9 e raised to power 3t over 1 plus 2 e raised to power 3t. What else? We need it in this form. Okay, so that means we need to divide by e raised to power 3t divided by e raised to power 3t divided by e raised to power 3t. So it cancels out. We get 9 over 1 over e raised to power 3t is minus 3t plus 2. That was the question, right? Yes, all right. Find the long-term population of goats predicted by the second model. Okay, so same way we did that. So as we know that for e raised to power x functions as t or sorry, in this case over here, we know that for e raised to power x, when x approaches infinity, e raised to power minus x approaches 0. So same way, e raised to power as t approaches infinity, e raised to power minus 3t approaches 0. So as t approaches infinity, x would approach 9 over 2, which is 4.5. That means the population would be long-term population. Therefore, long-term population would be 4,500 because x is in thousands. All right, moving on. Figure 3 shows a sketch of the curve with parametric equation. The curve meets at y-axis at 2 and at x-axis at k, where k is a constant. State the value of k. So this is the point where y is equal to 0. So 2 cos t. So at k, y is equal to 0. So therefore, 2 cos t is equal to 0. Right, okay. So this would mean that cos of t is 0 also. So t is cosine only becomes positive 0 in pi by 2. So that's what the range we have. So up till pi by 2. So that's the t value. All right. So that's the t value where this is happening. We still need to find out the x value. So therefore, x value would be 6 times by pi by 2 and minus 3 sine 2t. 2 times by pi by 2. So sine of pi would be 0. So we will just have 6 by divided by 2, 3 pi. So that's the final answer. So therefore, k is equal to 3 pi. Use parametric differentiation to show that dy by dx is lambda cosecant t. All right. So first off, we need the dy by dt. That would be derivative of cosine is minus sine. So minus 2 sine of t. And the x over dt is going to be 6. And the derivative of sine is cosine. So 6 6 cos 2t, because oh, sorry, 6 minus 6 cos. All right. Yeah, okay. Now, we need the dy by dx. So dy by dx is dy by dt over dx over dt. So dy by dt minus 2 sine t divided by 6, 1 minus cos 2t. Now, since we need this in cosecant terms, we need to have a signed expression in the bottom. So we know that 1 minus cos 2t, the just cos 2t, can be written as 1 minus 2 cos squared t. So, so basically, this is what we are doing over here. So 1 minus cos 2t, that is just going to be. So this means minus 2 sine t divided by 6, 1 minus cos 2t. Now we need to recall what cos 2t is. So cos 2t, since we need a sign expression at the bottom because it's given as that we need a cosecant form, so we will use 1 minus 2 sine squared t. So 1 minus cos 2t would be 2 sine squared t. So this would become minus 2 sine t divided by 6 times by 2 sine squared t. So sine t and one of the sine t goes away. 2 and 2 gets cancelled. So we are left with minus 1 over 6 sine of t. So which means further minus 1 over 6 cosecant t. The point P with a parameter t is equal to pi by 4 lies on C. Tangent to C at point P cuts the y-axis at point N. So at point N, okay. Find the exact y-coordinate of N, giving your answer in simplest form. Okay, so basically we need the tangent to the curve. Right, okay. So we need two things. We need the x-coordinate at pi by t is equal to pi by 4. So at t is equal to pi by 4. That's what the question is, right? Yes, okay. So we need the x-coordinate. That is going to be 6 times by pi by 4 minus 3 cos 3 sine 2t pi by 2 times by pi by 4. Y-coordinate 2 cos pi by 4. These are the first two things. We need the derivative also. So 6 pi by 4. So 6 pi divided by 4 minus 3 pi by 2 is just 1. So basically just minus 3. So we get 3 pi by 2 minus 3. The other one, Cos pi by 4 is under root 2 over 2. So y would be under root 2. Now we need the dy by dx at t is equal to pi by 4. So you have minus 1 over 6 sine pi by 4. Sine pi by 4 is also under root 2 over 2. So minus 1 divided by 6 divided by sine pi by 4. So minus root 2 over 6. So now we just need the y-intercept because n is where it's cutting the y-axis, right? So we need to find the equation. So y is equal to mx plus c. So therefore c is y minus mx minus under root 2 over 6 times by 3 pi by 2 minus 3. So we need to figure this out. So simplifying further, you have root 2 minus root 2 6 times by, minus root 2 over 6 times by 3 pi over 2 minus plus root 2 over 6 times by 3. So this becomes root 2 minus 3 times by 2 is 6. So it's minus root 2 over 4 pi plus 3 root 2 over 6. So, right, okay. Simplifying further, this becomes root 2 plus root 2 over 4 pi minus 3 root 2 over 6. So what we can do further over here is we can add, this term and this term together. So this is what we need. Sorry, no, I did not mean to cancel this out. So when we add these together, you have root 2 over 4 pi plus root 2 over 6 root 2 minus 3 root 2 over 6 simplifies to root 2 over 4 pi plus 1 over 2. So because it becomes 3 over 6, so this becomes 1 over 2. So root 2 over 2. So this was the coordinate of n. So the y coordinate of n is this. So this is the y coordinate of n. Okay, moving on. The region bounded by the curve, the x-axis and the y-axis, is rotated through 2 pi radians about the y-axis to form a solid of revolution. Show that the volume of this solid is given by this. Okay, so the volume formula goes from pi y squared dx. So this is what we're going to do over here. This curve is rotated. However, this is a parametric equation, so we'll have to be a little bit careful. Okay. So the regions are about the x-axis to form a solid of revolution. Okay. The x-axis, the y-axis, bounded by the curve x-axis and y-axis. So that means x is between 0 and k. Okay, right. So this means that the volume is equal to pi y squared dx from 0 to k. Now, y is equal to, I keep forgetting, 2 cos t, and x is equal to 6t minus 3 sine 2t, 3 sine 2t. Right, okay. So y is in terms of t, so dx has to be in terms of t also. So dx over dt we found out above also, so this is 6 minus 6 cos 2t. So did we, right, okay. So y squared makes it 2 cos squared t. So we have pi y squared is 2 cos squared t, and dt is this thing basically, or dx is basically 6 minus 6 cos 2t dt. Sorry, this is also 2 also squared. Okay, now let's figure out what this entire thing is. So this becomes pi 4 cos squared t times by 6 minus 6 cos 2t dt. We will figure out about the 0 and the k later on in a second. So, all right. Now what we need to do is, obviously we can't deal with the squared term over here. So we will have to turn it to, we will have to convert it into its double angle form. That cos squared t can be written as 1 over 2, 1 plus cos 2t. So that's what we are going to replace it with. So 4 times by this, that becomes 4 divided by 2. So this becomes pi 2 times by, so that is just 2 plus 2 cos 2t times by 6 minus 6 cos 2t dt. Now we do the multiplication. 2 times by 6, 12. 2 times by minus 6, 12. 12 cos 2t plus 12 cos 2t, and then these two terms. So this becomes minus 12 cos squared 2t dt. Now the problem again is the cos squared 2t part. So we will do the same thing we did above. We will replace this with the double angle form. So we'll continue doing that. So, okay. So we have pi times by 12t. These two terms get cancelled, minus this 12 pi cos squared, that means divided by 2, 1 plus cos 4t dt. We will have the full also over here. We will deal with the limits in a second. So this is 12 pi t from lower limit to upper limit minus 6 pi times by that, or minus 6, basically 6 pi times by t plus the integral of cosine is sine 4t over 4. from lower limit to upper limit. So let's simplify. So 12 pi t minus 6 pi t minus 6 pi over 4, that means 3 over 2, sine 4t. Now we will plug in the limit. So we have 0 to k we found out somewhere. K was 3 pi. Okay, all right. So k was 3 pi. So, wait, sorry. Where did the k come from? Where the t was pi by 2. Okay, so that means it is from t is equal to 0 and pi by 2. Okay, right. So, right, okay, moving on. You can replace all of these by 0 to pi by 2, 0 to pi by 2, 0 to pi by 2, and 0 to pi by 2. All right. So we get 12 pi by 2. Oh, sorry. This can turn into, these two can turn into 6 because 12 pi t minus 6 pi t minus 3 over 2 sine 4 pi over 2 minus 6 pi 0 minus 3 over 2 pi sine of 0. So we get 3 pi squared 2 pi, so sine 2 pi is 0, so 0, and minus 0, and minus 0. So final answer is 3 pi squared. So therefore, volume is 3 pi squared. And that's the question. And thankfully, the paper is over. All right. So if you feel that you enjoyed learning through this, you were able to solve some confusion, or I helped you with some doubt, please do subscribe to this channel, like this video, comment on it if you feel that I was unable to explain a particular question well enough. Do ask in the comments, maybe I can do that again. And if you have any requests, do reach out to us again in the comments. You can use the link tree given in the links to approach us on WhatsApp, email, anywhere. If you want some last minute preparation before the exam, also we are available. All right, so see you in the next video. Bye bye.